Hello everyone, this is a lecture from the Essential Calculus Problem series on the North Campus Calculus channel. In this series, we focus on solving exactly one calculus problem per video involving limits, derivatives, or integrals. And in this lecture, we will solve the integral of cotangent to the power of 5x dx. And while solving such an integral of cotangent to the power of 5x dx, you should firstly remember that the derivative of cotangent x was equal to minus cosecant square of x. If you cannot remember this, you should write cotangent x as cosine x over sine x and take the derivative using the quotient rule. Okay. And also you should remember that cotangent square of x is equal to cosecant square of x minus 1. If you can't remember this, you should write again cotangent square of x as cosine square of x divided by sine square of x. And then let's write it cosine square of x sine square of x. Then you can write cosine square of x as 1 minus sine square of x sine square of x, and this will be equal to 1 over sine square of x minus sine square of x sine square of x. 1 over sine x is cosecant x, so this means that 1 over sine square of x is cosecant square of x, and also sine square of x over sine square of x is equal to 1. These two identities are really important. If you do not remember them, you cannot solve such an integral. They are important. And to solve this integral, we will use the reduction method. Reduction means to lower the exponent here. And the cotangent to the power of 5x can be written as cotangent cube x times cotangent square of x dx. We know that cotangent square of x is equal to cosecant square of x minus 1. So instead of cotangent square of x, we rewrite it as cosecant square of x minus 1. And we always use this same method when we have powers such as 7, 9, etc. And the integral becomes the integral cotangent cube x times cosecant square of x minus 1 dx. The same method is also used for the tangent to the power of 5x dx. Yeah, this means that the integral of cotangent to the power of 5x and the integral of tangent to the power of 5x have the same method while solving. Okay, you can look at the video that I solved the tangent to the power of 5x for that. Okay, we multiply them one by one. Then the integral becomes cotangent to the cube x times cosecant square of x minus cotangent cube x dx. And we can split this into two different integrals. First integral is cotangent cube x times cosecant square of x dx minus integral of cotangent cube x dx. And here, for the integral of cotangent cube x, we will use the exact same method that we used here for the cotangent to the power of 5x. Here we split cotangent to the power of 5x as cotangent cube x cotangent square of x dx. Here is the important part here is taking cotangent square of x, and for this integral we will write this part again as cotangent x times cotangent square of x dx. Why are we doing this? Because we know that cotangent square of x is equal to cosecant square of x minus 1. Always we use the same method. We split the cotangent square of x and then rewrite it as cosecant square of x minus 1. This is called reduction. Okay, then the integral becomes as, take this down, the integral is cotangent x times cosecant square of x minus 1 dx, and this is equal to again minus integral of cotangent x times cosecant square of x minus cotangent x dx, and take this again down, and let's split this integral again. If we split it, this will be cotangent x times cosecant square of x dx minus here, and this is minus, then this will become plus integral of cotangent x dx. And we can actually solve these two parts without using any pencil. This is really easy part, but you may not know how to do that. Why it is easy? Because we know that if we have any function, this function may be here, maybe it may be here, it may have a power, for example 5, 7, or etc., or it may be a square root. It's not important. What is important is that if this function have a derivative multiplied by dx, we always use substitution method. If a function has derivative multiplied by dx, we use substitution. This is the important part. We know that cotangent x has a derivative of cotangent x is equal to minus cosecant square of x, and this minus is not important. Okay, since the derivative of this is cosecant square of x, this is, as you see, multiplied by dx here and here, and this means that we will use substitution for both of these functions, integral parts. Okay, we will use substitution. For this integral, let's say cotangent x is equal to u. Then this means take the derivative of both sides, minus cosecant square of x dx will be equal to du. This means that cosecant square of x dx is equal to minus du. Then let's come to the integral. This is minus du, and cotangent x is u. And also for this integral we will use the same substitution method, and again we will say minus du for this and u for this. Then the integral here becomes integral of u cube minus du, take this minus outside du, and for this integral we again minus here and minus here, this becomes plus integral of u times du. And for this integral we again, let's write it cotangent x dx, and firstly we will solve those two problems, and then after that we will solve this. Okay, minus. To integrate this, we will add 1 to the exponent. The exponent becomes 4 and divide by 4. And for you, our exponent here is 1. We will add 1 to the exponent and divide by 2. Okay, then the integral of cotangent x dx. This means that 1 over 4 u to the power of 4 plus 1 over 2 u square plus integral of cotangent x dx. But our u was cotangent x, then minus 1 over 4 times cotangent to the power of 4x plus 1 over 2 times cotangent square of x. And also, let's take the integral of cotangent x. Cotangent x, in order to integrate the cotangent x, again, we should write it as cosine x divided by sine x. If you do not write it as cosine x divided by sine x, you cannot integrate it. Here we have sine x, and you see its derivative here multiplied by dx. Then we should again say that sine x is equal to, for example, t, and let's take the derivative. Cosine x dx will be equal to dt. This means that cosine x dx is dt and sine x is u. And the not u, t. Okay. Then the integral becomes 1 over t times dt. And the integral of 1 over t is ln absolute value of t, and t was sine x. Then the integral becomes ln absolute value of x. ln absolute value of x. Okay, then take this down. Okay, integral of cotangent x is ln absolute value of sine x. And since the integral is an indefinite integral, we will add a constant c. And the answer is this. In the next video, we will solve these integrals. Okay. In the next video, I will solve the integral of secant x dx. See you in the next video.